Hi all, Bones here from BSA Bantams. As you can see, we've got the race engine back together. So I've currently got my stepson going off into town to get me some aluminium, and I'll bring you in a little bit closer and I'll explain why. So the reason Justin's gone off into town to get me some aluminium is so I can make up a new a transition piece from this inlet manifold flange to a Mikuni rubber boot setup. These stud setters are for an amyl carb, so you can't just go putting a Mikuni carb on it. And I don't want to go modifying this. It's really substantially made and well made. So I'm just going to make up an aluminium transition piece to go on the face of this that will actually be wedged shaped, and the reason for that is a normal Bantam engine sits at about at that angle there. So when I bolt the Mikuni on, I want it to be level, and the reason I want it to be level is so your float height doesn't come into effect for any of your tuning or anything like that. So in the meantime, while I'm waiting for Just to come back from town, and it's a 50k round trip to go to town, I'm going to go back onto the D7 and have a look at this this rear brake, but we'll have a look at that now. Okay, so the issue we've got with the rear brake is that's in the fully central position, and you've only got to move it the slightest amount and the brake starts to drag. The bigger issue is that's the correct length brake rod, and if you know the D7 adjuster nuts, they're actually, the thread doesn't start till it's like back here. So what I'm going to do is I'm actually going to take this off, and I'm actually going to machine the brake linings. I'm just going to have a look at some of the witness marking on the brake shoes, but I think I'll just take a very small skim. So I'll make up an arbor to mount this up into the lathe, and we'll take a cut across the brake shoes and get them nice and round. So there's our arbor just blanked out, so that's where the brake backing plate will fit, and I'm just about to cut a 1/2 inch UNF thread on that so I can put a nut into so I can pull the brake backing plate up against that shoulder. My arm's probably in the way, sorry, but we're just cutting the UNF thread with a button die in the lathe at the moment. So tailstock just backing up to keep the stock nice and square when you're cutting the thread. My apologies if my arm's getting in the way. I've got limited space around the lathe to take footage. There's our arbor done. And so, time to fit it up and see how it looks. So we've got the brake backing plate mounted up, and I've noticed this has got a bit of a bend in it, and there's a bit of a run out in the backing plate, and I'm not going to start hammering around and doing things like that because these brake shoes will be machine concentric to where the axle is. So the other issue you've got to overcome is that these are slightly loose, and so if you see the pivot down here, it's got a little bit of fair wear and tear on it, but when you're machining it, it has the ability to move it around. So I'm going to take the brake arm off, put a washer in there, pull this up nice and tight before I start machining it, and that'll hold it rigid enough. I'm not going to go berserk and take any massive deep cuts or anything ridiculous like that. But I'm thankful for the swing of my lathe. If you look down the bottom there, I've got about 2 millimeters clearance on the bed. But anyway, it clears it. So yeah, I'm trying to think, I think that's an 8-inch swing on that lathe, or 6 inches over the carriage. But anyway, we just made it. So next little problem we had was that the actual pivot was had lateral movement in it. So we've put some washers here, clamped it all up so that's all rigid, because obviously that's got to have play in it so it can pivot normally. So this is allowing that pivot to float a bit. So it's a lot better now. Right, next job is, and I'm just going to, oh, you'll be able to see up here, you can see how the brake shoe sits back behind this recessed lip here. So I'm going to have a tool that's pretty angular and go in. There's only about 1/2 mm of clearance behind the side of the brake shoe and this face in here. So what I'm going to do is actually use a parting off tool, because it's nice and thin, because you've got to get in behind this, you've got to be able to machine in behind that lip. Okay, so it's going well. At the moment we are only making a cut on one of the brake shoes, and we're just taking a depth of cut of about 0.1 of a millimetre at a time. This is only the second cut, so you can just pick up there where you can see where the tool's up to on the brake shoe, and we're only cutting on one shoe. So rear brake's done. So what I've ended up doing is I machined a bit off the linings, as you saw. It took about 0.4 of a millimetre off one shoe before it started cutting on the other shoe. So it's certainly a lot better. Now I actually reduced the length of this a bit because about it's 1/4 of an inch of just hole without any thread in here. So I've set up the back wheel at probably its longest extension with a stretched chain, just to make sure everything works there, because that's the extreme. So I mean, that whole wheel will move back that way, which will also move this whole position down here. So we've got plenty of thread engagement in there now. So I'm pretty happy. A bit of mucking around, which I didn't really want to do, but anyway, that's what you've got to do. Next job is to put on a brake light switch. So we'll get into organising that. So now I've got to fit up the brake light switch. So what I generally do on a D7 is actually put a washer on there and I actually open that eyelet up and hook that end into the brake rod and make a little plate, like a teardrop shaped plate, that gets sandwiched in behind here and just holds the brake switch there. But we'll get stuck in. So there's our little mount plate for the brake switch, all marked out, drilled. Now we've just got to cut it out and dress it up on the linisher. So that's our brake switch set up in. Now I said I usually hook it through here, but I had a look and I've just hooked it through the top of the split pin, and I think that's actually a better idea. So the other thing about having a setup like this, you can see the plate that I've just made up that's sandwiched in between the P and peg and the P and peg mount. These work, they've got a little bit of travel, then the switch will activate. So if you don't like the amount of, or you think you're pushing down your pedal too far to get the brake light switch to come on, you can back the nut off, get this plate and actually rotate it around so that distance between there and there, or actually, well, there and there, actually increases. Just by rotating that plate further down will pull more tension on that spring. I think it's going to be pretty close, but I've got, as I said, I've got the option to be able to rotate that around, pull a bit more tension on. That way my wires can actually pass in under here, away from your brake rod, and then back up the spine of the frame when you're wiring it up. You could also run it straight from there to there on the inside, but I just get a bit worried about moving parts and things like that, whether it'd pinch a wire or something like that. But anyway, pretty happy with that. Looks pretty neat. So Justin's back from town with some aluminium bar stock for the adapter for turn the race engine from an Amel carb to a Mikuni carb. This is the CAD drawing I've done to get my angles and all that sort of thing. So, over to the lathe, and we'll start prepping the blank out. So we're just machining off down to our diameter here. I've got about 10mm to take off this. So that's our blank done. 75 was the required dimension, and that's what we got. So there's our blank done, hole bored up the middle ready to go, and if you think it's a fair lump of aluminium, you're absolutely right, but once I cut a wedge in it, I've also got to have enough thickness of material to be able to drill and tap to put studs in, and to be able to fully recess in a countersunk screw. So hopefully it'll work out all right. So over on the milling machine, and I'm just getting the indexing head set up. I've scribed a reference line here, and this is so once the job goes up in the milling machine, I'll actually scribe a line over here so I can reference it around at the same point. Vernier height gauge there. So that's our setup in the dividing head. Getting ready to machine the angle. That angle's been set, and we're going to be running a fly cutter over the top. Obviously I have to reposition the head on the milling machine to make it a bit higher, but we'll get stuck into it. So we're only taking a millimetre cut at a time, and the reason for that is this is pretty tall, and I don't want to get too much vibration in it. The cutter is a single tube high-speed steel fly cutter, and it's sharp. So I'll just keep whipping away at it, and we'll see how we go. A little bit challenging to see in the shadows there, and I apologise for that, but we're making headway. So that shadow's in a bit of a bugger of a position, but basically that's the shape of what we want, and we've got both sides done. So if you think it's a bit chunky, well it is. However, I have to drill and tap holes in one side, so I've got to have enough thickness at the bottom where it's the thinnest so I can screw a stud into it. So what we're doing now is actually drilling the holes through for the mount. So you can see just a bit where I've marked it out, and these are the holes that go through, and this is the face that will actually clamp up to the existing inlet manifold. So these holes will actually end up sort of drilling out the side, but it's not, it's just square to that face, but it'll be nowhere near in line to the bore or anything by the time it breaks through on this side. So our preliminary pilot holes are done, and now I'm just going through with the clearance drill. But I'm not actually going through all the way. I'm leaving that pilot hole on the other side so I can locate it a lot easier, because I have to do a counter bore and some other things for a socket air cap screw, but I'll show you that. So we'll just take this down so far, and we'll leave the pilot drill on the other side. And there's our mount holes for the existing manifold drilled through, not all the way because I have to turn it around and counter bore from the other side now, so we'll get onto that. So as you can see, that's the angle that the hole actually drilled through, so I've got to pick up on that angle, do a counter bore on that angle. So it might be it's a little bit difficult to explain, but we'll explain a bit more later on, and apologies for going handheld. I'm trying to, the light on the back of it makes it a little bit difficult to see. That might be a bit better. So that may explain things a bit better of what I've got to do. So that's the angle of the face where the drill broke out from the other side. So now I'm going to set up a 5/16 or 3/8 slot drill. That's a milling cutter, and just go down and machine a counterbore in that. So what we're doing now is the counterbore for the socket head cap screw. So there's our reduced head socket head cap screw now in place. So that's worked out well. Now I'll get over and I'll do this hole over here. Alright, just marking out the centre line for the two stud holes that actually have to come out of this side to take the Mikuni mount. Oh, really? So I really wish I had a marking out surface, but I haven't. So mill table's the next best thing. Okay, so now we're just drilling the tapping drill size for the M8 studs that are going to go in here. And that's our completed job. So I had to cut a bit of a relief out at the back here, just for the couple of fins. I've just put these are going to end up being studs, but I've just put bolts in so you can just see it. But you can see how that's the centre line through here. You can see how high up these socket head cap screws are going in on that angle. But yes, it looks like a great big lump of aluminium because that's exactly what it is. But you've got the Mikuni rubber boot that will bolt onto here is also pretty big as well. So, and to start profiling it and things like that, being a wedge shape, it's too hard to hold. So, I mean, I'm after functionality more than anything else. So, it's going to work a treat. I'm very happy. A lot of work, but very happy. So from this side, you can see how actually wedge shaped this thing ended up being. There's a couple of little jobbies to go. I've got to wait till I get the mount and transition the inlet with the actual Mikuni mount, and a little bit the same on the inside here where the hole's actually elliptical. But that's about it for this episode. So look, I really hope you enjoyed it, what we're doing and what we're up to. I'm really keen to get this engine running, but it'll be a week away at least. Waiting for the new carby and the bits and bobs to arrive. Plus, I've got a customer bike coming in tomorrow. This guy's driving 8 hours to drop a bike off here. We've got 3 days to sort of go through it. We've already done an engine rebuild for him, so we can just drop the engine straight in. But we're just going through the rest of the bike, getting that all up to speed. We are about to, if you haven't already, clock over 400 subscribers. So to each and every one of you, thank you very much. And if you've looked and you haven't subscribed, please hit subscribe or make a comment. It's really good getting that feedback, and I really enjoy it. So it's been a pretty long day, and it's been well over 30 degrees in the shed all day too. So time for one of these. I hope you've enjoyed it, and from all of us at Oz Bantams, we'll see you later.